Alright guys, so today we're going to be talking about the Wittig reaction. And this is a carbonyl-based reaction. So essentially we'll start off with a ketone or an aldehyde. Or an aldehyde right here. And then we'll react it with a special type of reagent that is specific to this reaction. And this is what we call an ylide. And essentially what an ylide is when you have a phosphorus that's bonded to three phenols. And we can understand what a phenol is by looking at this abbreviation right here, which is pH. So it's just a short way of writing that instead of writing out the whole molecule or the name. And then this phosphorus is bonded to the carbon right here with two R groups. And this type of carbon is a carbene. And we'll see why that is a little bit later in the mechanism. And essentially what you end up with at the end of the reaction is a double bond, not to an oxygen, but to a carbon that has two R groups. And we can see where that comes from right here. So here is the mechanism as follows. So first we'll bring in our carbonyl. And so in this example, we'll use a ketone. And then we're going to react it with our ylide. So we'll bring in our ylide right here. And it's important to remember the charges because they're really crucial to understanding the mechanism and getting it correct. So this carbon has a negative charge, which means it has a lone pair. So the lone pair is going to attack our carbonyl carbon, and this double bond is going to break and move electrons onto the oxygen. So now what we get is a molecule that now looks like this. We have our two R groups here. We have our O here. That's now a negative charge. And then we still have our bond to our phosphorus with a positive charge. So now what's going to happen is naturally the negative charge is going to attack our positive charge, and that's because the negative charge is electron rich. We'll draw an arrow like that, so the oxygen to the phosphorus. So now what we'll get is kind of the same molecule with a new bond formed between our oxygen right here and our phosphorus right there. Our phenols are still intact. And now what we can do is we can finally form our end product. And all we have to do is collapse this bond into a double bond between our carbons and move this bond up to our oxygen. So now what we'll get right here is our end product, which will be our double bond between our carbons and then our R groups right here. Additionally, we can focus on our end product and our byproduct right here, and understand that there's charges on the byproduct. And so what we can do, if we wish, is we can stabilize it by moving one of the lone pairs on the oxygen into forming a double bond between our oxygen and our phosphorus. So that would essentially stabilize it and create this byproduct right here. But of course, this part of a reaction isn't necessarily part of the complete mechanism that we need to get our end product by itself. So this is the Wittig reaction. It's pretty useful if you want to replace our carbon-oxygen double bond with the carbon-carbon double bond and extend that molecule via a carbon chain. So this is the complete reaction and mechanism for the Wittig reaction. I hope this helps. Have fun with it, and I'll see you guys in the next video.